In this video, I'm going to show you how to solve every SAT geometry question that's listed as easy from the SAT online question bank. So here we have triangles EFG and JKL are congruent, meaning they're essentially the same triangle. They have the same length sides, same angles. And they say E, F, and G correspond to J, K, and L respectively. So that's actually given when they write it like this, but the SAT always specifies it as well. So E corresponds to J, F to K, and G to L. So it's given if they write them in that order. So the first letter will go to the first, second to second, third to third. But they, again, will specify that for you. So if we draw a triangle, say this is E, F, G, JKL should be congruent, which means we can just copy this triangle and make it over here. You can also just redraw it. But we've got J corresponds to E, K to F, K to F, and L to G. So they give us that E is 45 degrees and F is 20 degrees. So this is not drawn to scale, as you can see. Now, if we were solving for G, you can use the fact that all of these angles will add up to 180 degrees, but they're actually not asking for G or even the equivalent L. They're asking for angle J, which is over here. We know that J corresponds to E. So if they're congruent triangles, even if they were similar, the angles would be the same. This will be 45 degrees, the same angle measure as E. In the figure, line M is parallel to line N. What is the value of W? So we have two parallel lines cut by this transversal T. And what's the measure of W? W is the angle measure here. Well, these are two corresponding angles. So corresponding angles, meaning that they're in the same spot on the parallel lines cut by the same transversal, will have the same angle measure. So this will also be 170 degrees. What I recommend with these ones that have a transversal cutting through two parallel lines, if there's only one transversal and the lines are parallel, then essentially there's two different angles you can have. And one of them will likely be acute, one of them obtuse. So if you've got two obtuse angles, they're probably the same. Now you should just memorize that corresponding angles are congruent, but if you want to check that, they look like they're the same, right? It's not like one of these and one of these. 170 degrees there, and for this one, it says, what is the area in square inches of a rectangle with a length of 7 inches, so it's one of the sides here, and the width of 6 inches? So they're both in inches, and we're looking for square inches. We just want to multiply the length times the width, which gives us 42 inches squared, 42 square inches for our area. The side length of a square is 55 centimeters. So square means that the sides are going to be the same and they meet at a right angle. So 55, 55. To find the area of a square, you just square the side. That's why it's called a square. We've got 55 squared. You can type that into your calculator on the actual test. There is a trick though when you're multiplying or when you're squaring something that ends in 5, where you take the digits before the 5, in this case, it's also 5, and multiply that by 1 more than itself. So 5 times 1 more than 5 is 6. 5 times 6 gives us 30, and then tack on a 25 at the end. I have another video that explains why that trick works, but this would be 3025, which is 55 squared, and that would be square centimeters. In the given triangle, AB equals AC. So they mean the length of AB is equal to the length of AC. They're two congruent sides. And angle ABC has a measure of 67 degrees. So that's this one down here. We'll name it such that the middle letter is where the angle is originating. You can also call that angle B. And since these two sides are congruent, that means that the angles across from them, the opposite angles, will also be congruent. It's an isosceles triangle. So if this is 67, then this over here is also 67. What is the value of X? So we're finding this angle up top. Well, we know that the angles of any triangle will add up to 180 degrees. So we could do 67 plus X is equal to 180. 67 plus 67 makes 134 degrees. Sorry, my dog I don't know what he wants right now. Just wants some attention. All right, well, 134 plus X equals 180 degrees, or X degrees. So we can subtract 134 from both sides, which gives us that X equals 180 minus 134, which is 46 degrees. So X is 46. In the figure above, well, it should actually be figure to the left, lines L and M are parallel. Y equals 20 and Z equals 60. So this is 20 degrees down here, and Z is over here, that's 60 degrees. What is the value of X? Well, we also have two parallel lines cut by a transversal. In this case, the transversal is one of the sides of a triangle, but this is a corresponding angle here. So if y is 20, then this angle up here will also be 20 degrees. And now we can use the fact that the angles of a triangle will add up to 180 degrees. We have this 20-degree angle plus the given z, which is 60 degrees, plus x degrees, all adds up to 180 degrees. So 20 plus 60 gives us 80 degrees. 80 plus x degrees is equal to 180. Now we can think what plus 80 makes 180, or just subtract 80 from both sides. Either way, it will give you that x degrees is equal to 100 degrees, so x equals 100. All right, Bob. Okay. He gets a little confused at night. All right. Right triangles PQR and STU are similar, where P corresponds to S. So P is the same as S, and that means Q is going to be the same as T for the angles. If the measure of angle Q is 18 degrees, so 18 degrees up here, that means that T will also be 18 degrees. What is the measure of angle S? Well, we know the angles of a triangle add up to 180 degrees. We have a right angle that's 90, so that takes away 90 from the 180, leaving us with 90. So 18 degrees plus the measure of angle S would add up to 90 degrees. You could subtract 18 from both sides, giving us that the measure of angle S is equal to 72 degrees. The area of a square is 64 inches, or 64 square inches. What is the side length in inches? So you could say it's S times S gives us 64, so S squared equals 64. Now, if this was an algebra problem, this would be two answers. It could be positive or negative 8, but since it's geometry, you can have a negative length. We can just do the square root of both sides. That gives us that S is equal to 8 inches. So 8 inches will be the length of the square. In the figure, line M is parallel to line N. What is the value of W? So we've got, again, parallel lines cut by a transversal. This is very similar to the question from earlier. They're corresponding angles, so they're going to have the same measure. This will also be 134 degrees. In triangle XYZ, the measure of x is 24 degrees. Let's do x is 24 degrees. And the measure of y is 98 degrees. So in Z, what is the measure of Z? So this is just another one that the angles in a triangle add up to 180 degrees. You could do 24 plus 98 plus the measure of angle Z add up to 180 degrees. 24 plus 98 would give us, let's say that's 122 degrees plus the measure of angle Z equals 180 degrees. Subtract 122 degrees from both sides. Gives us that the measure of angle Z is equal to 180 minus 122 would be 58 degrees. In the right triangle shown, what is the value of sine of A? Well, sine, if we do SOHCAHTOA, sine of an angle is equal to the opposite over the hypotenuse, that's SO, S-O-H. So in this case, A is here. Opposite A means across from A, that's going to be 35. And the hypotenuse is the side across from the right angle, that's 171. So it's just 35 over 171, which is option B. The lengths of the legs of a right triangle are shown. Which of the following is closest to the length of the triangle's hypotenuse? All right, well, we have the two legs. So if we did the Pythagorean Theorem, we'd do a squared plus b squared equals c squared. C being the hypotenuse, the side we don't know in this case. So we have 3 squared plus 7 squared is equal to c squared. 3 squared gives us 9, plus 7 squared gives us 49. So 9 plus 49 gives us 58 is equal to the hypotenuse squared. And again, to get rid of a square in a geometry problem, you could just do the square root. You don't have to worry about plus or minus the square root. So the square root of c squared will just be c. And the square root of 58 You could type that into a calculator to estimate it, but we know that the square right below that is 49, which is 7 squared. And the square right above that is 64, which is 8 squared. So it's going to be somewhere between 7 and 8, and the only option that's somewhere between 7 and 8 is 7.6. If you want to test it out, you could also just write out 7.6 times 7.6, and you'll see that it will be something similar. So 6 times 6 gives us 36. 6 times 4 is 42, so it'd be like that. 4.56. And then 7 times 6 is 42. 7 times 7, 49. Something like that. 50, and then we can just add these together and we get 57.76, which is very close to 58. All right, so 7.6 is the closest of these options. This is an irrational number because 58 is not a perfect square. So if you do the square root of it, it will go on forever without repeating. But 7.6 is the closest of those options. Now, another way you can do this one without using a calculator is just we know that the hypotenuse is the longest side of a right triangle, right? So it has to be, the hypotenuse must be longer than either of the legs or both of the legs. In this case, C is our hypotenuse, so C has to be longer than 3, and more importantly, it has to be longer than 7. So we can quickly rule out A and B, because both of those are shorter than one of the legs, this 7. And we also know by the triangle inequality theorem that no one side of the triangle can be longer than the other two combined. So 3 plus 7 gives us 10. 10 is not even a possible length for a side of the triangle there, right? Basically, you can think of it as A plus B has to be greater than C, because the fastest way to get from this point to this point would be a straight line, not going down and then over. So 20 is also impossible. So just using the process of elimination, C was the only possible answer there as well. Now here we have which equation shows the relationship between the side lengths of the given triangle. Well, we have a right triangle, so it's just going to be the Pythagorean theorem again. A squared plus B squared equals C squared, where A and B refer to the legs. In this case, that's 4 and B. So 4 squared plus B squared is equal to the hypotenuse C squared. So do we have anything like that? That would be option C. It's just the Pythagorean theorem with the lengths that are given substituted in. A rectangle has an area of 63 square meters and a length of 9 meters. What is the width in meters of the rectangle? Length is 9. Then we know that 9 times W will give us 63. 9W equals 63. You could divide both sides by 9 or think what times 9 gives you 63. In that case, it would be 7. So the width will be 7 square meters and meters, so it will be 7 meters. In the triangle shown, what is the value of tangent of x degrees? So tangent is TOA, if you do SOHCAHTOA. So we can think of that as tangent of theta is equal to O, which is opposite, over A, which is adjacent. So opposite of x, that means the one that's across from x, is 26. And adjacent is the one that's touching it that's not the hypotenuse. This is the hypotenuse, so the one touching it is 7. So it'd be 26 over 7. All right, that's option C. The perimeter of triangle ABC is 17 inches. That's when you add up all of the sides. So let's draw it not to scale. So AB plus BC plus AC would all add up to 17. The length of side AB is 4 inches. The length of side AC is 7 inches. What is the length of side BC? Well, we know 4 plus 7 plus BC, let's call that x, would add up to 17. 4 plus 7 is 11, so 11 plus x equals 17. Again, you can think what plus 11 gives me 17, which would be 6, or just subtract 11 from both sides. 17 minus 11 is also 6. So this would be 6. To check it out, 4 plus 6 is 10, plus 7 is 17. In triangle XYZ, the measure of angle x is 23 degrees. The measure of angle y is 66 degrees. What is the measure of angle z? So if we draw out a triangle, we'd say x is 23, y is 66, and z is the one that we don't know. So 23 plus 66 plus the measure of angle z adds up to 180 degrees. Any triangle will have all of the angles add up to 180 degrees. So 23 plus 66 gives us 89 degrees. 89 plus the measure of angle z equals 180. Now we could just subtract 89 from both sides. It gives us the measure of angle z is equal to 91 degrees. So 91, that's option C. In the figure, line M is parallel to line N, and line T is a transversal. It intersects both lines. What is the value of x? Well, in this case, this is our first parallel lines cut by a transversal that's not using corresponding angles. We have x here, which corresponds to this, and then we've got this 33 degrees, which would correspond to this spot. Now, what they correspond to is the linear pairs of each other. So basically, 33 is here, and 33 and x form a line together. They're a linear pair, means two angles that add up to a line, and a line would be 180 degrees. So that means that 33 degrees plus x degrees is equal to 180 degrees. Now we could just subtract 33 from both sides, and that gives us that x degrees is equal to 147 degrees. And I can just get rid of the degree symbols on both sides. X is 147. In triangle RST, so let's draw a triangle, and not drawn to scale. They give us R is 63 degrees. We don't know what S is, and we don't know what T is. Now, the only thing we know is that all of the angles have to add up to 180 degrees, and you can't have a negative angle with an actual triangle. So 63 plus, we can call it the measure of angle S, plus the measure of angle T, we don't know either of those, would all add up to 180 degrees. That means that the sum of the measure of angle S and the measure of angle T would be equal to 180 minus the 63 degrees that was given. So we could subtract 63 from both sides. 180 minus 63 gives us 117 degrees. So these two combined add up to 117 degrees. They can't be more than that. Neither of them can be more than that. And technically, both of them have to be at least a little bit less. It could technically be 116.99 and 0.1 or 0.01, but it has to be less than 117, so both of them are an actual angle, right, that exists. It can't be 0. So anything above 117 we can cross off, which leaves us with just A. Right? Even 118 is close to that, but that would need 118 and -1. You can't have a negative angle. All right, so this one's probably the weirdest one that we've had, or the one that maybe involves the most critical thinking, just because it's a little outside the box. You probably haven't seen a question that would ask you like which could be an angle, but you're just using the multiple choice options here, and 3 of them are impossible. This one you could probably narrow down. The way that it's impossible, unless they gave you a negative angle there, is that it would be too big, so it makes sense that it's the smallest angle. That's the only way they could eliminate other ones, is if they're too big. Rectangle P has an area of 72 square inches. If a rectangle with an area of 20 square inches is removed from the rectangle, what is the area in square inches of the resulting figure? So we don't need to know the lengths and the widths. We just know we have 72 square inches, and then we are removing, which means we're subtracting 20 of those square inches. So we're removing this chunk of it. So we just do 72 minus 20, which gives us 52 square inches. So option D. All right, this is another one. This one's not very challenging, but it's just what it's asking might be a little bit confusing, because you probably haven't seen a question like this in geometry class. In the right triangle shown, what is the value of A? Well, this one, we are given the right angle, so that's 90 degrees, and we're given this 13 degrees. So we know all of the angles of a triangle add up to 180. So 180 is equal to 90 plus 13 plus A. Subtract 90 from both sides, we get 90 equals 13 plus A. Right, the other two angles of a right triangle that are not the right angle also have to add up to 90. Now we could subtract 13 from both sides, which gives us that A is equal to 77 degrees. At a certain time and day, the Washington Monument in Washington, D.C. casts a shadow that is 300 feet long. Right, so we've got the monument, 300 feet right here. At the same time, a nearby cherry tree casts a shadow that is 16 feet long. Right, so this is going to be similar triangles, it looks like. Given that the Washington Monument is approximately 555 feet tall, which of the following is closest to the height in feet of the cherry tree? Well, the sun is at the same spot, so you're going to assume that it's going to make the same angles, and that would mean that these are two similar triangles. So we could set up a proportion. We could say either x over 16 is equal to 555 over 300, or you could say x over 555 equals 16 over 300. So either of those will work. I'll do the first one. Again, it doesn't matter because you're going to end up getting the same answer for x either way. Just before I even solve it, note that the height is bigger than the shadow for the Washington Monument, so the same thing should be true here. Right? X must be bigger than 16, or else I messed it up. All right, so we just multiply both sides by 16, and that gives you that x equals 555 times 16 divided by 300. And even if you did it the other way, where you set up x over 555 equals 16 over 300, you would multiply both sides by 555, get the same numerator, 555 times 16, the same denominator, 300. All right, so this is another thing you could just type into your calculator. I don't want to do that, so I'm just going to show you could divide this by 5, divide this by 5, and it gives you 60. Now we could divide 16 by 2, which gives us 8. 60 by 2 gives us 30. Then we can divide it by 2 again. 8 becomes 4, 30 becomes 15. 111 has a multiple of 3. So we can see 111 divided by 3, 1, so 37. So if you divide this by 3, you get 37. Divide this by 3, you get 5. So we have 37 times 4 over 5. Now, let's see, 37 times 4, 120 is 30 times 4, plus 7 times 4 is 28. So 120 plus 28 gives us 148. And if you divide that by 5, 5 goes into 120 times, and it goes into 45 9 times. So it'd be something a little bit above 29, which the closest to that is 30. And again, if you type that into your calculator, you don't have to worry about doing any of that division. But 555 times 16 over 300, again, will give you 29 point, let's see, it would be 3/5, which is 0.6. So 29.6 rounds up to 30, which will be the height of the tree approximately. Now, part of the reason that they're approximating it is because it's not a whole number, but also because the sun, will not cast the exact same angle on the two things because they have different heights. So it's an approximation anyway, but 30 will be your closest answer. In the figure above, AD intersects BE at C. AD intersecting BE at this point C. So that's right here. If x equals 100 degrees, or x equals 100, so this angle up there, angle B is 100 degrees, what is the value of y? Well, we can use the fact that we know 20 and 100 here, angle A and angle B, to find this angle, angle BCA. So 100 plus 20 plus the measure of angle BCA, you could also call it ACB, would equal 180, because they're a triangle, all the angles add up to 180. So 120 plus what makes 180? Well, that would mean that the measure of angle BCA is 60 degrees, right? You could also think of it as subtracting 120 from both sides. But this here is 60 degrees. And now we have a vertical angle, which is two angles that are across from each other like this, made by the same two lines. That means they're going to be congruent. So this will also be 60 degrees. So now that we have this 60 degrees, we also have the 40 they gave us, we can figure out y using that same trick that all of the angles add up to 180. So this 60 that we solved for with the vertical angle, plus the given 40, plus the measure of angle y, or measure of angle d, which is y degrees, would add up to 180 degrees. 60 plus 40 makes 100. So you could think what plus 100 makes 180, y degrees must be 80 degrees. Also think of it as subtract 100 from both sides. So that means that y would be C 80. Triangle ABC and triangle DEF are similar triangles, where AB and DE are corresponding sides. All right, so we can draw our triangles. If they're similar, that means all of the angles are the same in the same spots. Assuming they label it correctly, where the first goes to the first, second to the second, third to third, but let's just check that. AB is right there, DE is right there. Okay, so we've got that correctly. If DE equals 2 times AB, so that means if AB is x, DE is double that, so DE would be 2x. And the perimeter of triangle ABC equals 20, what is the perimeter of triangle DEF? Well, DEF, all of the sides are going to be doubled. With similar triangles, not only are all of the corresponding angles the same, so A is the same as D, B is the same as E, C is the same as F, but also the sides will be in the same ratio. So if you have to double AB to get DE, you also have to double BC to get EF, double AC to get DF. So all of the sides are doubled, which means if you add them up, then the sum will be double. And that's what the perimeter is, it's just adding up all the sides. So if the perimeter of this one is 20, then the perimeter of this one, perimeter of triangle DEF, would be equal to 2 times the perimeter of ABC, which we know perimeter of ABC is 20, so 2 times 20 gives us 40, and I don't remember the units. I don't think it gave units, but whatever. 40, which is option B. Perimeter is just one dimension, even though you're moving right in a two-dimensional space, you're just measuring a length. It's in inches or meters or feet, it's not going to be squared. So you don't have to square the scale factor. If your scale factor is 2, then you just multiply the perimeter by 2. What is the area in square centimeters of a rectangle with a length of 34 centimeters and a width of 29 centimeters? We just do length times width. I know that's not drawn to scale at all, to find the area. So 34 times 29 will be our answer. Probably you just do this on your calculator, but I'll just write it out using this. Oh, actually, let's do it. 30 plus 4 times 20 plus 9 in parentheses. So we distribute 30 times 20 gives us 600. 30 times 9 gives us 270. 4 times 20 gives us 80. 4 times 9 gives us 36. So 270 plus 36, I'm adding those because 7 and 3 add up to 10. So that gives us 306. And then plus 600 plus 80. Well, 600 plus 300 is 900. So 980, and our units place would be 6. So 986 should be the answer there. They don't ask for units because they ask, what is the area in square centimeters? So 986 square centimeters is your area. When you bubble it in, you just bubble in 986. That's one, probably use your calculator if you don't want to potentially mess up your multiplication. Also something you could do, you could check it, right? Maybe do it by hand and with the calculator if you have the time to do so. The lengths of two sides of a triangle are 4 centimeters and 6 centimeters. If the perimeter of the triangle is 18 centimeters, what is the length in centimeters of the third side? Well, I don't even want to draw the diagram here because they gave us 2 of the sides. 4 plus 6 plus the third side we don't know, but that's how you find the perimeter of a triangle. You just add up the 3 sides. That's equal to 18. So 4 plus 6 plus x equals 18, x being that third side. 4 plus 6 is 10. So what plus 10 would give us 18? X has to be 8. You could also think of it as subtract 10 from both sides. So 8. And you just check your answer quickly. 4 plus 6 plus 8 gives us 18. That's what we want. In the triangle above, A equals 45. So this is 45 degrees down here. What is the value of B? This one's just measuring, or this is just testing if you know that all of the angles on a triangle add up to 180. Also note that it's 2B down here, not B. So just read carefully. They give us 31 plus 45 plus 2B adds up to 180 degrees. 31 plus 45 is 76. So 76 plus 2B equals 180 degrees. Subtract 76 from both sides. That gives us that 2B is equal to 104 degrees. Now we can divide both sides by 2 to get B alone, because we don't want 2 times B, we want just 1B. And that gives us that B equals 104 divided by 2, which is going to be 52 degrees. So 52. If you want to check that, just do 52 times 2 is 104. 104 plus 45 plus 31. If you type it in your calculator, it should give you 180 if you did it correctly. In the figure, 2 lines intersect at a point. Angle 1 and angle 2 are vertical angles. So we can see these two are vertical angles. Vertical angles are congruent. The measure of angle 1 is 72 degrees, which means that the measure of angle 2 is also 72. And that's what they're asking for. All right, so this one's that simple. Just know that vertical angles are congruent. You had to find this angle up here. They're linear pairs. Right, 72 and this are linear pairs, so they would add up to 180. But vertical angles don't add up to 180 unless they happen to be right angles. They're just going to be congruent. In the figure, 3 lines intersect at point P. If x equals 65, so this is 65 degrees in here, y equals 75, this is 75 degrees down here, what is the value of z? Well, we have here, P is not an angle, so don't get thrown off by that, that's just the point there. But you have x plus this angle here, which is not labeled, plus y, make a line. Right? They all add up to this line. So that means that x, which is 65 degrees, plus, let's call this angle down here maybe A for angle, 8 degrees, plus A plus 75 degrees adds up to, again, a straight line, and a straight line is 180 degrees. Now, the reason A is going to help us is because A forms a vertical angle with Z. So that means that those two angles are congruent. If we know A, then that's the same thing we know what Z is. So 65 plus 75, that would give us 140 plus A is equal to 180. So we just subtract 140 from both sides, or think what plus 140 makes 180. And that will give us that A is equal to 40 degrees. All right, so if A is 40 degrees, then again, Z is a vertical angle, Z is congruent, Z will also be 40 degrees. So that one also took a little bit more critical thinking than some of the easy questions, but still not too difficult. Just don't get thrown off by this P here. Like you might think that you have to do something with it going this way, that P is not an angle. And if they didn't label one of the angles, just you can make up a label for it if you want to keep track. A rectangle has a length of 13 and a width of 6. So we have 13, 6, like that. What is the perimeter of the rectangle? So this one, they're trying to trick you because some people are just going to multiply them and give you the area there, which let's see if that's an option. 60 plus 18 would be 78. Okay, they were nice. They didn't actually make that an option, But for the perimeter, just make sure that you add up all four sides, so the two lengths and the two widths. You could do 2 times L plus 2 times W, or just draw out a diagram to keep track. 13 plus 13 is 26, plus 6 is 12. 26 plus 12 gives us 38, so 38 will be our perimeter. In the figure shown, line M is parallel to line N. What is the value of x? So again, we have two parallel lines cut by a transversal. These ones are not corresponding, but they correspond to each other's linear pairs. So x is over here. This is the same as x degrees there, which 26 and x, if they're a linear pair, again, that means that the two create a line together, which means they add up to 180. They're going to be supplementary. So 26 degrees plus x degrees equals 180 degrees. Just subtract 26 from both sides. And that gives us, this is going to be 154 degrees. So x is 154. In the figure above, lines L and K are parallel. What is the value of A? Well, in this case, we've got this angle corresponds to this angle, and the 64 degrees corresponds to this angle. So again, A and 64 are going to be supplementary. You can see one of them is acute, one of them is obtuse, so they're definitely not the same. A plus 64 equals 180. So subtract 64 from both sides gives us that A is equal to 116 degrees. Or A degrees is 116 degrees, so A is 116. In triangle ABC, the measure of angle B is 52 degrees, and the measure of angle C is 17 degrees. What's the measure of angle A? So without even drawing them out, you could know that all the angles add up to 180, so 17 plus 52 plus A would make 180. I'm just going to draw a not to scale diagram just so that it's a little bit easier to keep track. I didn't even draw it to scale, so this should be much thinner, more acute to make it 17. That looks like maybe it could be about 52, but this other angle up here should be definitely bigger than those other two. It should be the biggest angle. 17 plus 52 degrees plus measure of angle A adds up to 180. 17 plus 52 would give us 69 degrees. So 69 plus the measure of angle A equals 180. Subtract 69 from both sides. That gives us the measure of angle A is equal to, I think that would be 111, which is option D. And then to check it, just do 111 plus 17 plus 52, make sure it adds up to 180. The circle above with center O has a circumference of 36. What is the length of minor arc AC? All right, so AC is right there. Well, we know that this is a right angle. They drew that in there. They didn't say that, but if this is a right angle, then the measure of this arc is 90. So it's 90 over 360. It's 1/4 of the entire circle. And if the entire circumference is 36, then we just can do 1/4 of 36. So 1/4 of 36 is going to be 9. Right, 9 plus 9 plus 9 plus 9 would be 36. So that's how you do that. To find an arc length, you have to figure out what proportion of the entire circle it is, and then multiply that proportion times the circumference. Some people will also write it out as, like, they'll set up two proportions. So they'll say, like, 90 degrees over 360 degrees is equal to x, so the length of the arc, over the circumference, 36. So you could also do it that way and cross multiply and solve for x. It will also give you 9, which you can see here, just 90 over 360 is equal to 9 over 36. That makes sense. Just you take away the 10 from each of those. But again, you can just figure out what fraction of the entire circle it is and multiply that by the circumference as well. In the given figure, side AC extends to point D. If the measure of angle BAC is equal to the measure of angle BCA, what is the value of x? All right, well, we can see here, if the measure of angle BCA, so they're saying if these two angles are the same, it's an isosceles triangle, I don't think the lengths matter, but we can find this measure BCA because it is supplementary to this 110 that's given, right? They are a linear pair, they form a line together. So 110 plus the measure of angle BCA equals 180 degrees. So subtract 110 from both sides, or think what plus 110 makes 180. The measure of angle BCA has to be 70 degrees. So this will be 70, and if these two angles are congruent, then this is also 70. And now to find x, you're using the same formula we've been using for a lot of these, which is just that all the angles inside of a triangle, all the interior angles of a triangle add up to 180. 70 degrees plus 70 degrees plus x degrees equals 180 degrees. 70 plus 70 is 140. So 140 plus what makes 180? X is going to be 40. Right? And if you want to test that, just 40 plus 70, make sure that you did that math correctly as well. Also, there is a trick. Now, it doesn't help so much on this one, but if they give you an axial angle, so in this case, the axial angle is 110, that axial angle is equal to the other two angles in the triangle added up. So 70 plus in this case we said x was 40, 70 plus 40 is 110. So that does check out, assuming that we did the 70 correctly, which we did, because, again, we did this supplementary angle, and then these two are congruent. But that trick sometimes will help you speed up. Sometimes you can just use a trick like that to check that your math is correct. In the figure, line J is parallel to line K. So we've got two parallel lines cut by this transversal T. What is the value of x? Well, these ones, you actually don't even use line K at all. It's kind of just there as a red herring, but we've got a linear pair, right? These two add up to a line together, so they're going to be supplementary. So we have x plus 133 is equal to 180. Just subtract 133 from both sides, give us that x is equal to 47. Right, and that one you might want to check it on your calculator, just be sure. But 130 plus 50 would be 180, and then you just take away 3 from the 50. That's how I did that in my head. What is the value of x? Again, it's x degrees, so the angle here is 47 degrees, but because they have the degree symbol there, x is just going to be 47. So that's all you'd have to bubble in. I don't think they ever have you bubble in a degree symbol or the unit. So just make sure that your units are correct is the main thing. The triangle shown has a perimeter of 22 units. If x equals 9 and y equals 7, and they're both units, what is the value of z? Well, the perimeter is just all those added up, so x plus y plus z equals, what is it, 22? So 22 equals x, which is 9, plus y, which is 7, plus z, which is what we're solving for. So 9 plus 7 gives us 16. 16 plus what would be 22? That would have to be 6. So we'd say z could be 6. You could also subtract 16 from both sides. Either way, 22 minus 16 will also give you 6. All right, so 6 is that. And just to check it, you could do 6 plus 9 is 15, plus 7 is 22. In the figure shown, line C intersects parallel lines S and T. What is the value of x? Well, in this case, this x corresponds to this angle here. So we'd say this is x down here. And then these two, 110 and this x that corresponds to the above x, would make a linear pair. So 110 plus x. Now you can notice the trend here, that whenever they have these lines, these parallel lines cut by one transversal, if it has two transversals, it gets a little bit harder. You have to actually think about it. With these ones, either the angles are going to be congruent, so they'll be the same angle measure, or they'll be supplementary, so they'll add up to 180 degrees. And again, you just look at it, this one's clearly acute, this one's clearly obtuse. Notice this one's less than 90, this one's greater than 90. So they can't be the same angle. In that case, it gives you a hint that they're probably going to be adding up to 180. So 110 plus 70 would give us 180, so x is equal to 70. Right, you can also subtract 110 from both sides, 180 minus 110 is 70. Triangle ABC and DEF are congruent, or triangles ABC and DEF are congruent, where A corresponds to D, B to E, and it would be C to F. Oh, B and E are the right angles. So, okay, let's just draw it out. Say B is here, E is here. Did they say they're congruent? Yeah, so they're the same lengths of sides as well. Say A to D, C to F. The measure of angle A is 18 degrees, which means that D is also 18 degrees. What is the measure of angle F? Well, we said this is also 18 because they are in the same spot. So F is going to be the one we have to find. Just 18 plus 90 plus F would add up to 180 degrees. And since this is 90, you can subtract that 90. Just know that the other two angles of the triangle are 180 minus 90, which is 90. So 18 degrees plus the measure of angle F adds up to 90 degrees. Subtract 18 from both sides. That gives us the measure of angle F is equal to 72 degrees, which is option B. A right triangle has legs with lengths of 11 centimeters and 9 centimeters. So let's draw that out. We know the legs are going to be the ones that are not across from the right angle. So this would be 9, this would be 11. What is the length of this triangle's hypotenuse in centimeters? So this just uses a squared plus b squared equals c squared. So a in this case we could say is 9. So 9 squared plus 11 squared equals the hypotenuse squared. 9 squared is 81 plus 11 squared is 121. 81 plus 121 gives us 202. That's equal to the hypotenuse squared. To get rid of the squared, we can do the square root, because again, it's a geometry problem. You can't have a negative length for the hypotenuse. So this cancels out, just gives us c. C is equal to the square root of 202, which is option B. What is the area in square centimeters of a rectangle with a length of 36 centimeters and a width of 34 centimeters? The area is just going to be the length times the width for a rectangle, so we just do 36 times 34. Now, without even multiplying them, 6 times 4 is 24. So if we have something ending in a 6 and something ending in a 4, it's going to also end in 4, which is the end of 24. So you can quickly rule out all of these and know that it's D. Just to check it, I will actually multiply it out. And if you have a calculator on the test, you can just use that. But 4 times 3 is 2, so it's 144. 3 times 6 gives us 18. 3 times 9, so that's that. Get 4. This is 2, carry the 1, 2. 1224, which is the answer that we already chose. So it's D, 1224. And I think the units were square centimeters. All right, in the figure, line M is parallel to line N, and line K intersects both lines, so that's the transversal. Which of the following statements is true? Well, X and 145 are vertical angles. They're across from each other, made by the same two lines, so that means they're going to be congruent. So if we have anything that says X is equal to 145, that would be our option. The value of X is less than 145, no, they're the same. The value of X is greater than 145, no. The value of X is equal to 145, yep, they're both the number of degrees of two congruent angles. And the value of X cannot be determined, no, that's not true. So it would be C, the value of X is equal to 145, it's 145 degrees. In the figure, line N intersects lines R and S, so N is our transversal here. Line R is parallel to line S. Okay, so parallel lines cut by a transversal. What is the value of X? Well, these are corresponding angles, right? They're in the same spot on their respective parallel lines cut by the same transversal. So that means X is equal to 162. So our answer will just be 162. Right? They're the same angle measure, X degrees and 162 degrees. For the right triangle shown, A equals 4, B equals 5, which expression represents the value of C? So it's just going to be doing the Pythagorean Theorem. A squared plus B squared equals C squared. They actually even label them that way, which is very nice of them. So A squared would be 4 squared, plus B squared would be 5 squared. It's equal to C squared. Now be careful. I guess they don't have the answer choice here. Some people might remember, 3, 4, 5 is one of the special right triangles, or not special, one of the Pythagorean triples. So very common one. But that would be with 3 and 4 as the legs. The hypotenuse always has to be longer than the legs. So in this case, it's going to be something bigger than 5, and it won't be a whole number. That's why the options here are not whole numbers. So 4 squared is 16, plus 5 squared is 25, is equal to C squared. 16 plus 25, that gives us 41, is equal to C squared. So we can do the square root of both sides. C is equal to the square root of 41. Now, they don't have that option, but they just did the square root before they added it. So square root of 16, or square root of 4 squared plus 5 squared. That'd be this option right here, D. You can also think of that as the distance formula. That's actually where the distance formula comes from, is you're making a right triangle. So it's the square root of the change in y plus the change in x. Right. All right, so the area of a rectangle is 630 square inches. The length of the rectangle is 70 inches. What is the width? All right, so they gave us the length. We don't know the width. So that means 70 times W, the length times the width is how you get the area, would be equal to 630. So what times 70 gives us 630, or divide both sides by 70? Well, we know 7 times 9 is 63, so if you divide both sides by 10, right, you'll get that this is going to be 9. Right, 70 times 9 is 630. So our width must be 9. What is the area of a rectangle with a length of 17 centimeters and a width of 7 centimeters? All right, so just always check, what are they asking for, the area or the perimeter? In this case, it's the area. Area is just length times width. If it's perimeter, you have to add them up, including the 17 here and the 7 here. But for area, 17 times 7, let's see, what would that be? 7 times 10 is 70. 7 times 7 is 49. So 7 plus 49 would give us 119. So 119 square centimeters. I guess we got some Memorial Day fireworks going off. But the area of a rectangle is 57 square inches. The length of the longest side of the rectangle is 19 inches. This is 19. What is the length in inches of the shorter side? So basically they're asking for the width again. And what did they give us? The area. So 19 times W, length times width, or long side times short side, would give us the area. So 19 times W equals 57. Just divide both sides by 19. 57 divided by 19, is that 3? 30 plus 27, yeah, that makes sense, okay. 3 times 19, you can check it, 30 plus 27 gives us 57. So the width would be 3, let's see, inches. Again, they say, what is the length in inches? So we just have to bubble in 3. In the figure, two lines intersect at a point. If W is 136, so this is 136 degrees, what is the value of Z? Well, they're just two vertical angles. So vertical angles are going to be congruent. That means that z is also 136. What is the value of z? Yeah, that's z. I don't know why they chose w and z, but a triangle has a base length of 40 centimeters. So this is 40. And a height of 90 centimeters. I assume it means the height from that same base. What is the area in square centimeters of the triangle? Well, we know that the area of a triangle, you can write it as 1/2 times base times height, or you could say it's base times height over 2. Those are the same thing. In this case, 40 times 90 over 2. I think the easier way to do that is to half the 40 to make it 20. So 20 times 90, because 2 times 9 is 18. And then just make sure you have the right number of zeros. So 2 times 90 is 180, and then you have to multiply that by 10. So it's going to be 1800. And you can also type that in your calculator. You could type it as 40 times 90 divided by 2, or 20 times 90, or 45 times 40. Either way, they'll give you 1800, or any of those ways. They'll give you 1800. It should be square centimeters, correct? Each side of a square has a length of 45. What is the perimeter of the square? So again, just be careful. A lot of people are going to rush this and do the area by squaring 45. They're asking for something that I think is actually even easier in this question, which is the perimeter. Now you could memorize the perimeter of a square as 4 times s, because all of the sides are the same. There are 4 sides. You can also just draw it out if you want to be super safe. 45 times 4, well, 45 times 2 is 90, and then double that again, it's going to give you 180. It's 180, what is it? It didn't give units, so just leave it as 180. Again, you can't bubble in units on the SAT. What is the area of a rectangle with a length of 4 centimeters and a width of 2 centimeters? So asking for the area. 4 by 2, you just multiply length times width. 4 times 2 gives us 8 square centimeters. A rectangle has a length of 64 inches and a width of 32 inches. What is the area in square inches of the rectangle? So you can notice they're kind of starting to repeat concepts a lot here on this easy section, because there's only so many things that they consider inbounds for an easy geometry question. So this would be just 64 times 32, length times width. We know 32 squared would be 1024. At least maybe you know that. That's 2 to the 5th. 10 to 24 is 2 to the 10th. And 32 times 32 would give us half of the area, because this would be half of 64 is 32. So we just double that, and that would be a very fun game that makes people waste a lot of time when they should be doing their work, is 2048. Right, so it's actually 2 to the 11th power. And the figure above, and this one, again, don't get intimidated if you're not one who likes mental math. On the SAT, you get a calculator the whole time, so you can just type that in, 32 times 64, or you have to write it out, do the standard algorithm. In the figure above, lines M and N are parallel. What is the value of B? So B is over here. They give us that these are both A. So let's see, what is the value of B? M and N are parallel. They give us that this angle here is 90. So that means that this is 90 and this is 90. So A and B are both in the acute angles of a right triangle, which means that A plus B adds up to 90. This is 130. We know that this angle down here is 50, because 130 plus this angle have to add up to 180. They make a linear pair. So we know that's 50. Let me see what else we have. Oh, okay. So we've got, this is transversal. These are alternate interior angles. So alternate interior angles are going to be the same if they're through two parallel lines, which M and N are parallel, cut by the same transversal. So that means that A is going to be 50. Okay, so that one, this could trip you up, because like the rule I said before, if you don't know, when two angles have to be the same, just note that if there's one transversal, they could both be acute, they're going to be the same. They're both obtuse, the same. If one's acute, one's obtuse, they add up to 180. This messes it up a little bit, because you have to actually kind of know that rule. But alternate interior angles, you can see, cut through like that. So this is 50, which means this other A is also 50. So 50 plus B adds up to 90. And I think I kind of skipped a step in my head there. I kind of spoke out what I was doing, but we've got a right angle. So you could think of it as A plus B plus this right angle, 90 equals 180. And then I subtracted 90 from both sides to get 2 here. All right, so 50 plus B equals 90. You just think what plus 50 makes 90? B has to be 40. You could also think of it as 90 minus 50 is 40. All right, so B is going to be 40 degrees. This one, that might be one of the few on here that involves kind of a couple of different concepts put together. It's still pretty easy, but it's just a matter of you have to keep track of alternate interior angles being the same. You have to keep track of the angles in a triangle adding up to 180 degrees, and this linear pair to get that 50. So there's kind of three different things in this one question. None of them are super difficult, but it's probably that is why this one might be on the more challenging side of the easy questions. In triangle ABC, AB equals 4,680 millimeters, and BC is also 4,680 millimeters. So it's going to be an isosceles triangle. Right, so let's see, they say AB and BC. So B is this side up here. AB and BC are the same. Right, they're both 4680, which means that angle A is equal to angle C, because the angles across from those congruent sides are also going to be congruent. All right, which statement is sufficient to prove that triangle ABC is equilateral? So if it's equilateral, that means that all three sides are the same. So AC is also congruent to these other two. So AC must also be 4680. So let's see. AC equals 4680 millimeters. Okay, that's all I had to do there. They're just basically testing if you know what equilateral is and if you can visualize all the stuff that they said. So, that one was not as challenging as I thought. In a right triangle, the measure of one of the acute angles is 51 degrees. What is the measure in degrees of the other acute angle? So we know it's a right triangle, which means that one of the angles is 90. And they give us that this one's 51. We have to find what the other one is. Well, I mean, we've said this a couple of times now. If you have a right triangle, the angles that are not the right angle have to add up to 90. But just to prove why that works, one more time, 51 plus x plus 90, right, the given right angle, would add up to 180, like any triangle. You could subtract 90 from both sides, and that's how you get the fact that 51 degrees plus x degrees adds up to 90 degrees. So subtract 51 from both sides, give us that x degrees is equal to 90 minus 51, which should be 39 degrees. Right, just to check it, 39 plus 51 plus 90, the right angle, adds up to 180. Right, so 39 is our answer there. And now we're on, I believe, the last page of these. This one says, a figure shows the lengths in centimeters of the edges of a right rectangular prism. So don't get thrown off by the right part. All that means is that, the height of the prism is at a right angle to the base, like the face down here. So that's pretty much any prism that you're dealing with in geometry is going to be a right prism. And I mean, like in geometry class in high school, you could get one that's slanted when you get to maybe a different level of math, but we don't have to deal with that. Luckily, on the SAT, they limit it mostly to the kind of geometry that you'd see in a geometry class. So the figure shows the lengths in centimeters of this right rectangular prism. The volume V of a right rectangular prism is length times width times height. So they even gave us the formula, where L is the length of the prism, W is the width of the prism, and H is the height. What is the volume in cubic centimeters of the prism? All right, so they gave us the length, the width, and the height, and they gave us the formula. So all you have to do is plug it in correctly. So we get 6 times 2 times 3. 6 times 2 is 12. 12 times 3 gives us 36. So 36 square centimeters, or actually it's cubic centimeters. 36 cubic centimeters would be our volume. In the figure above, and again, above means to the side here, because I had to fit it onto this page, two sides of a triangle are extended. What is the value of x? All right, well, we can find this angle up here, which is, again, not labeled. But 70 plus 50 plus, let's call it angle A, plus A adds up to 180 degrees, because the angles in a triangle always add up to 180. 70 plus 50 is 120. So 120 plus A equals 180. What plus 120 makes 180? A has to be 60 degrees. So this angle up here is 60 degrees, and then you can see that A and X form a linear pair. They make a line together. So 60 plus X adds up to a straight line. Subtract 60 from both sides, that gives us that X is equal to 120 degrees. Or they say X degrees, so it's actually, X is just 120. All right, the other way that you could do this is actually where you could have used that exterior angle trick I talked about earlier. The exterior angle, which X is the exterior angle to this angle that I labeled A, is equal to the sum of the other two, right? Because X is supplementary to A, and A adds up with these two to make 180. That's why that works. So X equals 70 plus 50, which is 120. So that's a fast way to do it. But, again, that only saves like maybe 10, 20 seconds, depending on how fast you did these steps. But it could be worth it if you're rushing at the end. Now here we've got, what is the perimeter in inches of a rectangle with a length of 4 inches and a width of 9 inches? Usually I hear it as like the length being the longer side, the width being the shorter side, but you can see here they don't actually care about that so much. We've got 4 by 9. What is the perimeter? All right, so be careful, don't find the area. They were nice and didn't make 36 an option here. So if you did multiply them and find the area, you would realize that you made your mistake. but just be careful with that. 9 plus 9 is 18, so it's 2 times the width. 4 plus 4 is 8, that's 2 times the length. 18 plus 8 gives us 26, so 26 would be our perimeter. In the figure, line P is parallel to line Q, and line T intersects both lines. What is the value of x plus 142? Oh, okay. So this one, you don't even have to do any math here. You just know that those two make a linear pair. So if you add them up, they're going to add up to a straight line, which is 180 degrees. They're going to be supplementary. So that's all you got to do there. And I believe, yep, that's the end of all of the easy geometry questions that are currently on the SAT question bank. In the description, assuming that they all fit in there, I will put timestamps for each of the questions. So if you do one of them and you want an explanation, you can skip right to it. Hopefully I was pretty thorough. You can see that in the easy geometry section, this was, I think, over 100 questions, but most of them had to do with either transversals through parallel lines, knowing those rules. They did a lot of areas and perimeters of rectangles and squares. I think there was one area of a triangle. There were a lot of questions that had to do with the angles inside of a triangle. So the fact that they add up to 180, sometimes exterior angles. There were a lot of linear pairs. So basically two angles that add up to a straight line. So they add up to 180. We had a couple that were volume, or was it just this one volume? Definition of an equilateral triangle. This was probably the one that involved the most steps. But again, it was also just a transversal question and a triangle question put into one. We had a perimeter of rectangle, perimeter of square. They did vertical angles. There were a few of those. What's the area? Oh, and Pythagorean Theorem. So make sure you know the Pythagorean Theorem. That will show up a lot on the easy questions. And I'm trying to see what else they had on here. I guess there were some that you could use the triangle inequality theorem to help. That wasn't this one. That was the one earlier. This one is just the perimeter of a triangle. So knowing that the perimeter of the triangle is adding up all of the sides. And there was one that had to do with arc length. There are more questions about arc length and arc measures and things like that in the medium and difficult sections. But this one was in the easy section, I guess, because they made the numbers really nice. But make sure you know that. I believe there's one sine and one tangent question in here as well. So make sure, just know SOHCAHTOA. You don't have to know anything with the unit circle. But a SOHCAHTOA and how to set that up would be the main thing there. But let me see. I don't think... Oh, similar triangles. So they also had that one with the Washington Monument and the tree, making sure that those are the same. Or sometimes they'll give you similar triangles and you have to make sure you understand the scale factor. But besides that, I think those are all of the concepts that you have to worry about on this easy set of geometry questions. Now, once you get into the medium and then the difficult, there will be a lot more concepts that are covered, or sometimes they'll use the same concepts thrown in. But if you know all of those things, again, areas, perimeters of rectangles, triangles, and squares. They had volume of a rectangular prism and just understanding some things with prisms, knowing that the angles on a triangle add up to 180, knowing the Pythagorean theorem, how to apply it, knowing SOHCAHTOA, knowing vertical angles, knowing transversals through parallel lines. That's going to be the most of the easy questions. So hopefully you can handle all of that. If you have any questions, feel free to leave them in the comments below, or if you found an error I made when I was going through them, hopefully I caught them myself, but feel free to comment that below. Or if you have a better method of solving any of the questions, please share it. All right, well, thank you for watching, and hopefully this was helpful. And here's, you might have heard him hooting and hollering a little bit at the beginning. You can see he's just hanging out now, but my buddy Bubba. But yeah, and thanks for watching.